So today we're going to be taking a look at pandas. No, not those kinds of pandas. Pandas for data science. So pandas is a ridiculously powerful library that's used all around the world for data science. It helps you work, process, and filter tabular data so you can get your machine learning models out there a whole heap faster. And it's probably one of the most useful libraries to have under your belt as a data scientist. Let's take a look in detail as to what we're going to be going through. So in this video, we're going to be covering CRUD for pandas. Now you're probably thinking, what the hell is CRUD? Well, it stands for create, read, update, and delete. We're basically going to be covering everything you need to get up and started really quickly as a data scientist using pandas. We're also going to be treating this like a bit of a crash course. So we'll read in some tabular data and we'll go through all the steps that you need in order to work with pandas. So in terms of how we're going to be doing this, we're going to be working with Python, and specifically we're going to be using the pandas library, and we're going to be coding inside of a Jupyter notebook because that's what data scientists all around the world are using. So you ready to get into it? Let's do it. All right, so let's dive straight into it. So in this video, we're going to go through everything you need to get up and started super fast to work with pandas for data science. So we're going to break up the video into 4 key sections. So creating data frames, reading data frames, and specifically we're going to be taking a look at how to work with all the data within them. We're then going to be taking a look at how to update them, so dropping rows and working with columns. And last but not least, we're going to take a look at how we can output all of our resulting data. So the first thing that we're going to want to do is import pandas. Now we can do that pretty easily using the standard Python import functionality. All right, so we've imported pandas using the import function, so import pandas as PD. Now, if we open up our pandas library and hit tab, you can see that we've got a whole bunch of stuff to work with there. We're not going to go through all of this. We're going to really focus on the 20% that's most important as a data scientist. And probably the most important function is read CSV. So this allows us to create a data frame from a CSV and work with it in pandas. So in this case, we're going to be using read CSV to open up our telco churn CSV here. So if we open this up, you can see that it's just a regular old CSV with a whole bunch of data. And it looks like we've got about 3,334 rows, 3,333 when you exclude our columns. Let's go ahead and read this in and create a data frame. Alrighty, so we've now just created our data frame. So in order to do that, we use pandas and we used the read CSV function, and then we pass through the name of our CSV. Now you can't actually see the data frame yet because we haven't actually gone and visualized it. Now we're going to skip on over to our read section just for a second to take a look at what this data frame actually looks like. In order to visualize our data frame, the easiest function that you're probably going to want to use is the head function. So this allows you to view the first 5 rows of data within your data frame. And you can see that we've got our data frame that we just read in. Now, as I said, the head function allows us to view the first 5 rows of data, but if we wanted to view more rows from the top, we can just pass through the number that we want to see. So by passing through 10 to our head function, we're now going to see our first 10 rows of data. Also, just to note, when working with pandas, our first row is going to be represented by the index 0. Alrighty, so we've now read in data from a CSV and we visualized the first top 10 and top 5 rows. Now what we want to do is take a look at how we might create a data frame from a dictionary. So a dictionary is just a different Python data type, but it allows us to work with a bunch of different methods. Also, when you're working with pandas, you've actually got a whole bunch of read functions here as well. So if you wanted to read in from your clipboard or Excel or read in from HTML, SQL, a whole bunch of other stuff, you can do that as well. Here we're going to be creating a data frame from a dictionary. So what we can do is create a temporary dictionary first. And then what we can do is create a data frame from this dictionary. So in order to do that, we just need to use pandas, access the data frame class, and then call fromDict. And you can see we've now created a data frame from a dictionary. So again, we can use the head function to visualize it. So this time we've created a data frame called dictdf. So what we can do is visualize that. And there you go. That's our data frame that we've created from a dictionary. So let's just quickly recap. So in our create section, we took a look at how to create a data frame from a CSV. We then also created one from a dictionary. But as I said, there's a whole bunch of other read functions in Pandas that allow you to read in data from different data sources. Now, within our read section, what we're going to be taking a look at is how to view our top 5 and bottom 5 rows. So we've already taken a look at how to read in our top 5 using the head method. We're also going to take a look at how we can view our columns, create summary statistics, filtering, and then working with indexes. So using the ilock and lock functions. So let's go on ahead and finish up our section 2.1. So we want to view our bottom 5 rows. Now that's pretty easy. All we need to do is use the tail method to do that. Alrighty, and you can see that we've now used the tail method, and this allows us to view our bottom 5 rows. Again, we can pass through a different number of values if we wanted to view a different number of rows. So again, say we wanted to view our bottom 15. Again, this allows us to view our bottom 15 rows. Alrighty, now on to section 2.2. So viewing columns and different data types. With Pandas, you've got a bunch of different columns. So you can see that we've got state, account length, so on and so forth. And we've got enough that we can view on the screen. But when you're working with really big data frames, you might want to be able to see all the columns that you've got available. To do that, all you need to do is use the columns attribute. And you can now see all the columns that we've got within our data frame. So state, voicemail, total day charge, blah, 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 so on. We can also take a look at the different data types that we've got available within our data frames using the dtypes attribute. So within our data frame, we've got a number of different data types. So we've got objects, integers, floats. We've also got our churn value as an object. Sometimes you'll also see Booleans and a bunch of other different types of data types, but we've pretty much covered the majority of them here. So this just tells us all the different types of data that we've got within our data frame. Now, whenever you're working on a data science project, probably the most important step of the CRISP-DM lifecycle is understanding your data. A great way to get a handle on your data is to calculate summary statistics. So we can do this using Pandas and specifically using the describe method. So using the describe method, we're able to calculate our count, our mean, standard deviation, min, max, as well as our different quartiles. So this gives us a good overview of what our data actually looks like. But if you pay close attention, when we've called the describe method, it's only being called on the data types that are either integers or floats. What happens if we wanted to calculate these summary statistics on objects, for example? Well, we can do this simply by passing through a different parameter to our describe method. So specifically, if we call df.describe, what we need to do now is pass through include equals object. So this allows us to calculate summary statistics on our non-float and integer values. So for state, international plan, voicemail plan, and churn, we're now able to get our counts, the number of unique values, as well as our top values and the frequency. So that pretty much covers summary statistics. And now let's take a look at how we can filter on columns. So we took a look before at all the different columns that we've got. How do we actually filter on the specific columns that we want to visualize? Well, first up, let's actually take a look at how we can grab a single column. So we've got our state column here. How do we go about grabbing that state column? Well, that's pretty easy. All we need to do is access that state value. So you can use it like a bit of a key. Now, this can get tricky when you've got keys that have a space in them, because if you take a look at international plan here, for example, we can't actually type in df.international plan. It's going to throw an error. In order to get columns that have a space in them, we need to do this a little bit differently. So all we do is pass through a square bracket and treat it like a key that way. So again, it's doing the same thing, it's just a different way to grab a column. So that allows us to grab a single column. Now what happens if we wanted to grab multiple columns? Well, right now it doesn't look like we can grab 2 columns using this method or this method. So in order to grab 2 columns, what we can do is a similar method to what we used for our international plan, except this time we're going to pass through an array of the columns that we want. And you can see by passing through an array within our data frame sort of index, we're now able to grab both our state and our international plan. I should also note that I'm going to share this entire Jupyter notebook with all the code completed inside a GitHub repository. It'll be in the descriptions below. I'd also love to know what you're using Pandas for. Definitely leave a comment in the comments below. Alrighty, so back to our column. So we've now gone and shown our 2 different columns. Now again, whenever we're performing our exploratory data analysis step using Pandas, what we might like to do is find our unique values within each one of these columns. So what we can do is call the unique method to grab our unique values. And just like that, by calling unique on our state column, we're now able to get all the unique values within our data frame. Likewise, say we wanted to call it on our churn column, for example, which we've got here, we can just change that state value to churn, and we're now able to see all the unique values within our churn column. So that covers filtering on columns. So we've taken a look at how to grab a single column, how to grab a single column where there's a space in between it, as well as how to grab multiple columns and how to grab unique values. Now, what happens if we wanted to filter on rows? Well, let's take a look at the rows that we've got. So say we wanted to grab rows that had international plans set to no. Well, what we can do is use condition-based filtering to grab those values. So by passing through our data frame, then selecting the column that we want to filter on, as well as the condition, we're able to grab only the values that we want. So this is particularly useful when you want to filter your data frame or grab a subset of values. Now you can also filter on two different columns or have multiple conditions. You just need to tweak this code a little bit. So let's copy this. And say we wanted to take a look at values within our data set where customers churned, so customers left our business, and they weren't on the international plan. So international plan is going to stay as no. All we need to do that is pass through our different conditions inside of parentheses. So let's put in our first condition inside of a set of parentheses, then pass through an ampersand to represent and. So we're basically concatenating all of these conditions together. And then we want to pass through our second condition, which is customers that didn't leave the business. So now what we're going to do is specify a different column. So in this case, we're filtering on churn, and we want customers that didn't leave, so false. And now you can see that we're actually filtering on both our international plan column as well as our churn column. If we wanted to see customers that weren't on the international plan and did churn, all we need to do is change our second condition to true. And now you can see that we've been able to filter on rows. So what we've done is we've taken a look at our top 5 columns, we've filtered on rows where international plan equals no, and then we've also done a dual condition filter in order to pass through additional conditions to that filter. Again, you can stack more of these together if you wanted to build bigger filters. Now what we're going to take a look at is how we can index with iloc. So indexing allows you to filter through your data frame, but instead of using specific values or specific conditions, we're going to be using integers. So say we wanted to grab our 15th row within our data frame. Well, we can do this pretty easily using the iloc method. And there you go, we've now grabbed our 15th row. So what we've done there is we've taken our data frame and then we've used the iloc method and then passed through 14. Now you're probably thinking, why 14? Well, remember at the start that I said that your data frame begins at row 0. So if we wanted our 15th row, we just need to subtract 1, and this is going to give us our data frame. Now the iloc function is really, really powerful. So it allows you to hone down and get the specific data that you want. So say, for example, you only wanted the state value as well. Well, we can extend our iloc method and just pass through our first column. So when we pass through two different parameters, the first is going to be your row, the second is going to be your column. So by passing through column 0, we're going to get our first column. And again, you can see we're now getting our state. Likewise, we can also change this and pass through -1, and it's going to go the other way. So now we're getting our last column, which is churn. Now we can also use the iloc function to do slicing. So say we wanted a subset of our data frame, so rows 22 to 33, for example. Well, what we can do is take a slice of our data frame using the iloc function. So we've used the iloc method the same way, except this time what we've done is we've passed through a segment of our data frame that we want. So we want to start at row 22 and grab everything to row 33, excluding it. So you can see that we've now gone and grabbed that slice. So that really covers how to work with iloc. So it's really an integer-based filtering function. Now we can also work with the lock method. So the lock method works a little bit differently to the iloc method in that it uses keywords instead of integers. So in order to do that first, you need to have an index set on your data frame. So right now by default, when we read in our data frame, our index is just going to be created as a set of integers. That's why we've got these numbers here. What we can do is actually set an index on a specific column that we want. So say we wanted to set it on state, we can do that. Alrighty, so you can see that we've now gone and set an index on state. So in order to do that, we took a copy of our data frame. We then went and set our index and passed through the column that we want our index on. And we also passed through the in place parameter. So this is going to allow it to do it in that data frame without having to create a copy of it. Then we've gone and visualized those first top rows, and you can see that state is indeed our index. Now what we can do is use the lock method to filter through our data frame and grab the specific rows that we want. So say for example, we only wanted rows which were in Ohio. Well, what we can do is use the lock method to do that. So there you go. So we've just used the lock method to go and filter through our data frame and just grab rows that are situated in Ohio. And that about wraps up our read section. So we've now gone through how to show our top 5 and bottom 5 rows, show our columns and data types, create summary statistics, filter on rows, and we've also done some indexing with iLock and lock. Now it's time to get to updating. So the first thing that we're going to take a look at is how to drop rows. So whenever you're pre-processing your data frame, one of the steps that you're probably going to want to do is drop values that have nulls. Now what we can do is actually calculate the rows that have nulls using the isNull method. So by chaining together isNull and sum, we're able to see the number of rows that have missing values. In this case, it's represented by the different columns. So it looks like we've got 10 rows missing total day minutes, 10 missing total day calls, 8 missing churn, a whole bunch of others there. Now with pandas, we represent these as NAs. So what we can actually do in order to drop these rows is use the drop NA function. So by using drop NA and then passing through in place equals true, we're able to drop all the rows that have missing values. So if we go and visualize this again, you can see that we now have 0 missing values within our data frame. So what we did there is we just visualized the number of rows that have missing values, and then we've gone and dropped all of those values. Now what we can also do is we can drop columns. So say we didn't actually want a column, for example, say we wanted to drop area code, for example. What we can also do is drop a column using the drop method. So let's do that. So simply by using the df.drop method, we're able to drop a column. So in this case, what we've done is we've dropped the area code column, and we've also passed through access equals 1, because in this case, we're dropping a column, we're not dropping a row. What about creating columns? So say for example, we wanted to create a column, which was the sum of total night minutes and total international minutes. So what we can do is really quickly add a new column and add those together. And there you go, that's how you create a new calculated column. So what we basically did is we grabbed our total night minutes plus our total international minutes, and then we've added those together and we've put it in a new column called new column. So if we go and take a look at these now, you can see that our new column is there on the far right hand side. So what we can also do is say we weren't happy with the values in this. Well, what we can do is update that entire column. So say we wanted everything in here to read 100. Well, we can grab that column and set it equal to 100. Now, if we go and visualize it, everything within that column is reading up as 100. So that's gone and updated everything in that column. What happens if we just wanted to update a single value? For example, our first value here. Well, this is where we can use iLock to go and replace those values. So let's go and grab our first column and then set it to 10. Now, if we go and visualize that column, you can see that it's now reading as 10. So what we did is we first grabbed the value using iLock. So we grabbed our first row, which is 0, and then we grabbed our last column, which we can access by passing through -1, and then we set that value to 10. So you can see that that's now reading as 10. Now the last update methodology that I want to walk you through is how to use the apply function. So the apply function is super powerful because you can basically iterate through every value within a specific column or within your data frame and make updates appropriately using conditions. So say we wanted to take our churn column, and rather than it being represented as falses and trues, we wanted it represented as ones and zeros in a new column called churn binary. Well, because there's different conditions there, what we need to do is have a little bit of filtering in order to determine how to update that value. This is where the apply method comes in. And there you go. So we've gone and used the apply method on our churn column, and then we've used Lambda to basically iterate through each one of these values. And we've also used a expression here. So we've basically said it's very Pythonic. So we've basically said if x equals true, set it to 1, else set it to 0. So if we go and take a look at our columns now, you can see that we now have a churn binary. So let's double check that we've done that for our true values as well. And you can see that if churn equals true, our churn binary equals 1. So apply is really, really powerful because you can even pass through functions in here and make updates that way. Just a key point to note out, x is going to represent the value that you're iterating through at a point in time. That's why we've said x equals true. All right, and that about wraps up our updating section. So what we did is we dropped some rows and we specifically dropped our NAs. We've also dropped some columns. We've created new calculated columns. So specifically we added our night minutes plus our international minutes to create our new column here. We took a look at how to update an entire column, how to update a single value, and last but not least, we took a look at how we can use the apply method to provide conditional based updates. The last thing that we're going to do is take a look at our delete and output section. So say we wanted to output our data frame to a CSV, output it to JSON, or output it to HTML. This is where we're going to do it. So the first thing that we're going to take a look at is how to output our data frame to a CSV. This is pretty easy. All we need to do is type in df.toCSV and then name it. So what we'll do is we'll just call it output for now, .csv. This is going to output in the same folder that our Jupyter Notebook is in. So you can see if we scroll over here, we've now got an output.csv dataset. So you can see that we've got our columns that we made updates to. Those are all represented within that data frame. Now, likewise, we can also output to JSON. For example, if you're working with different web components, working with JSON is obviously super useful. That's pretty easy. All we need to do is type in to JSON, and it's going to create all of the JSON for our data frame. Likewise, doing it for HTML, sort of similar method. And now we've got a HTML representation of our data frame. So again, we've just passed through to HTML to get the HTML, to JSON to get the JSON. And if we wanted to delete our data frame, all we need to do is type in del df. So this is a Python method that allows us to get rid of a specific object. And that about wraps up our last section, which is outputting and deletion. So we outputted to CSV, to JSON, to HTML, and last but not least, we deleted our data frame. And that about wraps up this Python crash course. So what we did is we went through how to create data frames, how to make updates to them, how to read them and change data. And last but not least, we also took a look at how we can output our data and delete it. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to hit subscribe, tick that bell so you get notified of any future videos that I release. And if you've got any questions at all, I mean anything, be sure to drop a mention in the comments below and I'll get right back to you. Thanks again for tuning in. Peace.